Now we're going to write another rule that's probably not as easy to do because I did not give you the first term or the common difference. So you need both of these in order to write your rule. So if I copy down my formula again, a sub n equals a sub 1 plus n minus 1 times d. I want to point out a few things here. I've already kind of pointed out that this n will always match with that n. But if you notice here that there is an a sub 1 that matches with that 1. So what I'm going to do is I'm going to replace those with what's given to me. So I have a sub 27, so I'm going to start with that just because it's the bigger number. And I'm going to write a sub 27 right here. Equals, instead of a sub 1 now, I'm going to use a sub 8. Plus, instead of writing n minus 1 now, my n right here is 27, minus my 1, instead of being a 1, is now an 8. Like all that nice color coding. And again, I still do not know what d is, so I'm going to put that there. Now maybe you're looking at this and thinking, well, there's still way too many variables. We can actually replace those variables because we know that a sub 27 is actually equal to 97. So I'm going to put a 97 right here. I know a sub 8 is actually equal to 21, so I can replace that with a 21. 27 minus 8 is 19, d. And now if you look, you can just solve for d. So subtract 21 from both sides. 97 minus 21 is 76, equals 19d. Divide both sides by 19. And my common difference is 4. So I've got one of the two things that I really need. Now I need to go back and find a sub 1. So this would be our next step. I'm probably going to just, well, you could pick either one of these. You pick what you want. I'll just stick with the a sub 27 because that's what I used in this spot anyway. So I'll just use this one. If you want the smaller numbers, you could do the a sub 8. So again, instead of a sub n, I'm going to use a sub 27 equals, I still don't know a sub 1, so I'm going to write a sub 1 because that's what I need, plus n is really that 27 minus 1. Notice in the parentheses always matches with these subscripts. So here I had 27 minus 8 because I had subscripts 27 and 8. And then my d is now a 4. I can replace a sub 27 with 97, so I've got 97 is equal to a sub 1 plus 27 minus 1 is 26. And now I can actually solve for a sub 1. So let's see, 26 times 4 is 104. A sub 1 plus 104. Subtract that from both sides. 97 minus 104 is going to give me negative 7. So now I have the two things that I need to actually write a rule. So this one's got a lot to it. All right, last step here. A sub n. I never plug in anything for the n when I'm getting my rule, so this should be my last step. Instead of a sub 1, let me write this all down. I'm going to plug in negative 7 for a sub 1 plus n, we don't know, it's in n because it's the rule, minus 1, and then d is equal to 4. So I can go back and distribute. A sub n is equal to negative 7 plus 4n minus 4. Oops, I'm almost off the screen. Combine like terms. I've got a sub n is equal to negative 4 and negative 7 gives me negative 11 plus 4n. That was a lot of work. So if you're given two terms, like you were here, you're going to want to replace the a sub n and the a sub 1 with what's given. All right, if you still need more help on that one or you need some more examples, I definitely have more, but we've got a couple more things we need to do. We've got a couple word problems. All right, I cheated a little bit here. I wrote this all out so you didn't have to watch me writing all this. So if you want to push pause and copy this down, go for it. But a marching band is arranged in rows. The first row has 3 band members. So if you want to, you can draw yourself a picture. You've got 3 people in the first row. Each row after it has 2 more band members than the row before it. write a rule for the number of band members in the nth row. So remember, whenever you're asked to write a rule, you should think, I need two things. I need the first term, and I need the common difference. So I know this is a very wordy problem, but if you look, I tell you that there's 3 in the first row. So there's my first term, right there. And then I say each row has 2 more, which means it's going to go up by 2, so my common difference is 2. So this actually is way easier than that last problem we did, because all I need to do is plug in my a sub 1, a sub n minus 1, I can't talk and write that, sorry. All we have to do is plug in a sub 1 and d into this formula. Remember, do not plug in anything where you see the n's when you're doing your final rule. So I just replaced a sub 1 and d. Distribute, a sub n is equal to 3 plus 2n minus 2. Combine like terms, and I've got 3 minus 2 is 1 plus 2n. There's my rule. So then if somebody says, well, how many people are in the 20th row? All you'd have to do is plug in 20 to figure out how many people there are. All right, one more. All right, the last one we're doing here is asking us to find the number of multiples. How many multiples of 6 are between 100 and 650? And this is actually one that gives people a little bit of trouble. So, you know, don't tune out now. I know it's the last one, but so I'm asking for how many. So really, I'm asking for n. I want to know how many there are. What we need to do is we need to find multiples of 6 that are between 100 and 650. So what I would say to do is start with a list. So we know we've got 100, 101, 102, on and on and on. Are any of these multiples of 6? And so to check that out, just get your calculator, and I would do 100 divided by 6. Nope, it comes out as a decimal, so that's not a multiple of 6. 101 divided by 6. Nope. 102 divided by 6. Yes. Okay, so that's my first multiple of 6. There's a sub 1. Now, if I keep going, remember there's a whole bunch of numbers in between here. The last number that we're looking, to include would be 650. Before that would be 649. Before that would be 648. Before that would be 647. I'm going to try to find my last term. So again, I'm going to do the same thing again. I'm going to go 650 divided by 6. Nope. 649 divided by 6. Still a decimal. 648 divided by 6. Yes, there it is. So this right here is my last term, my a sub n. Now, think about this. If I want these to be multiples of 6, my first number in this sequence is 102. My next multiple of 6 is going to have to go up by 6, so that would be 108, because that went up by 6. If I go up by 6 again, I'm at 114. Go up by 6 again. Keep going. The last number in this list is going to be 648. Since these are multiples of 6, that's telling me that d is equal to 6. So what I can do now is I can write a rule. If I write a rule, remember, all I need to write a rule is a sub 1 and d. So if I've got a sub n equals a sub 1 plus n minus 1 times d, I could plug in a sub 1 and d and I could get my rule. The problem is I want to know, remember, how many. I'm looking for n. The nice thing here is that I told you where to stop, so this technically is my a sub n, so I can plug 648 in here. I just don't know what term that is. I know my first one is 102 plus, I don't know how many terms there are, but I do know that my common difference is 6. So then I can solve for n. So there's a couple different things you could do. Most people would probably distribute, which is fine. I'll do that if you want to, but if you do minus 102 minus 102, 648 minus 102 is 546 equals n minus 1 times 6. You sure can go ahead and distribute. I want to make this go a little bit faster, so I'm just going to divide both sides by 6 to get rid of that right away. And so then I've got 91 is equal to n minus 1. Add 1 to both sides. N is equal to 92. So that's telling me that there's 92 numbers that are multiples of 6 between, what was it, 100, between 100 and 650. So, it's got a good ACT question, actually. All right. Go ahead and make sure you got all this copied down. Any questions, make notes about it, and I will help you tomorrow. Bye-bye.